Solving for the steady-state level in the Solow Growth Model. The Solow Growth Model, developed by economist Robert Solow in the 1950s, is a fundamental framework in intermediate macroeconomics used to analyze long-term economic growth. One of the key aspects of this model is solving for the steady-state level, where the economy reaches a point where capital per worker and output per worker remain constant over time. In this article, we will explore how to solve for the steady-state level within the context of the Solow Growth Model, including the roles of the population growth rate, depreciation rate, and savings rate. Understanding the Solow Growth Model. The Solow Growth Model is grounded in the production function, which typically takes the form of a Cobb-Douglas function. Y equals F, K, L, equals K caret backslash alpha L caret, 1 dash backslash alpha. Where Y is total output. K is capital. L is labor. Backslash alpha is the output elasticity of capital, 0, backslash alpha, 1. In this model, economic growth is driven by three main factors: capital accumulation, labor growth, and technological progress. However, for the purpose of this article, we will focus on the first two factors and how they relate to solving for the steady-state level. Key components of the steady-state level. 1. Savings rate. The savings rate, S, is a crucial determinant in the Solow Growth Model. It represents the portion of output that is saved and reinvested in the economy. A higher savings rate leads to more capital accumulation, which can increase the steady-state level of output per worker. The relationship can be expressed as backslash delta K equals SY backslash delta K, where backslash delta K is the change in capital. Backslash delta is the depreciation rate of capital. 2. Depreciation rate. The depreciation rate, backslash delta, reflects the rate at which capital stock loses value over time due to wear and tear. In the steady state, the amount of capital being accumulated through savings equals the amount being lost through depreciation. Thus, the steady state condition can be summarized as SY equals backslash delta K. 3. Population growth rate. The population growth rate, N, affects the labor force and, consequently, the steady-state level. As the population grows, the economy must also grow to maintain the same level of capital per worker. In the steady state, the capital per effective worker remains constant, which can be represented as backslash frac, dk, dt, equals sy, n plus backslash delta, k. Where n plus backslash delta is the effective depreciation rate, accounting for both capital depreciation and labor growth. Solving for the steady-state level. To find the steady-state level, we set the change in capital per worker to 0. This entails solving the equation SY equals n plus backslash delta, k. Substituting the production function into the equation gives sk caret backslash alpha L caret, 1 dash backslash alpha, equals n plus backslash delta, k. Dividing both sides by k, and rearranging yields. Sk caret, backslash alpha 1, L caret, 1 dash backslash alpha, equals n plus backslash delta. By simplifying, we can express the steady-state level of capital per worker, k caret asterisk, as k caret asterisk equals backslash left, backslash frac, s, n plus backslash delta, backslash right, caret, backslash frac, 1 dash backslash alpha. This formula illustrates how the steady-state level of capital per worker depends on the savings rate, population growth rate, and depreciation rate. Example: calculating the steady-state level. Let's consider a hypothetical economy with the following parameters. Savings rate, S, equals 0.25. Depreciation rate, backslash delta, equals 0.05. Population growth rate, N, equals 0.02. Output elasticity of capital, backslash alpha, equals 0.3. Using the steady-state formula, we can calculate k caret asterisk equals backslash left, backslash frac, 0.25, 0.02 plus 0.05, backslash right, frac 1 to 0.3. Calculating the denominator. N plus delta equals 0.02 plus 0.05 is equal to 0.07. Now substituting back into the formula. K equals left, frac, 0.25, 0.07, right, frac, 1, 0.7. K approximate, 3.5714, 1.4286. Approximate 5.24. Thus, the steady-state level of capital per worker is approximately 5.24 units of capital. Understanding how to solve for the steady-state level in the Solow growth model is essential for grasping the dynamics of economic growth. By considering the savings rate, depreciation rate, and population growth rate, learners can better appreciate how these factors influence long-term economic outcomes. The Solow growth model provides a robust framework for analyzing these relationships, making it a cornerstone of intermediate macroeconomics. For further reading and scholarly sources, consider the following links. Solow Growth Model, Khan Academy. The Solow Growth Model, Investopedia. Economic Growth, MIT OpenCourseWare.